In today's video, we're going to look at operations with polynomials, part 1, okay? And that's going to start with us defining what a polynomial is. So we'll look at the definition, we'll look at standard form of a polynomial, and how to name a polynomial. That way when you hear the terminology, you understand it. And then we're going to focus on adding and subtracting polynomials in this part, and we'll do 3 examples there, okay? So your success criteria, okay, so you know you've got it. If you can recognize when an expression is a polynomial, when you can add two polynomials by combining like terms, subtract polynomials by distributing the negative and then combining like terms, and then write a polynomial in standard form. So these are kind of the 4 skills that we're going to be working on here. So let's look at identifying polynomials. When I say polynomial, what is it, right? So here's your mathematical definition, which I'll read part of. A polynomial is a mathematical expression involving the sum of powers, that's important, okay, in one or more variables multiplied by coefficients. A polynomial in one variable is the sum of terms of the form ax to the k, which I've written over there, okay, where a is any real number and k is a non-negative integer, okay, and then it just goes on in more detail. So that's a lot to explain the definition of polynomial. Here when they talk about powers, sum of powers, this we call a power or a term, okay, and it's made up of a coefficient, a variable, and an exponent, okay, which we've seen most of those things before. So a polynomial is just when you're adding a whole bunch of those together, right, adding or subtracting. So like here's an example down here, and we're going to actually simplify the definition of that. So a polynomial is the sum of terms with non-negative integer exponents. Right? So it's a sum of terms, adding or subtracting, with non-negative integer exponents. So that means like your whole numbers, 0, 1, 2, 3, 4, and so on. Your exponents have to be one of those, okay? So here's an example here, negative 2x plus 4x to the 2 plus 3x to the third minus 8. Each one of these being multiplied together is a term. So this one has 1, 2, 3, 4 terms. If we look at the exponents, this is really an understood exponent of 1, x to the 1. Right? This has an x to the 2, x to the 3, and when you don't have a variable, that's actually the same as x to the 0. So all of our exponents are non-negative integers. So we have a polynomial. So that's it. When I say a polynomial, I'm just talking about something like that. Okay? There is a standard form of writing a polynomial, okay? And it's when we order our exponents from highest exponent down to the lowest. So if I wanted to pick out the highest exponent here, which term has the highest exponent? Yeah, it's your 3x to the third. So that's what would come first. So I'm just going to write 3x to the third first. And then we're going to go down from there. So the next highest exponent is x squared. So I would do plus 4x squared. Then it's our x to the 1. Notice it's a negative 2. Okay? So this is a positive 4, positive 3, negative 2, and a negative 8. Make sure you keep the signs correctly. Okay, so that would be a negative 2x, which is next to the 1. And then our last one is our constant, or x to the 0. So this is what we call standard form, highest exponent down to the lowest, okay? And we can name polynomials based off of their degree, which is their exponent, highest exponent, okay, and the number of terms. So the highest exponent you have, right, so here our highest exponent is x to the third, is going to determine your degree. So that's a third degree, which we call a cubic. Okay? And then the number of terms. We have a name for the first 3. If you only have 1 term, it's called a monomial. 2 terms is called a binomial, and 3 terms is called a trinomial. Anything higher than 3 terms, like what we have here, we just call a 4-term polynomial, or just a polynomial. So if I wanted to name this, I would say it is a cubic, because of the x to the third, 4-term polynomial, because it has 4 terms. Okay? And your degrees, you can have constant, linear, quadratic. We're going to look at lots of quadratics this year. Cubic, quartic, quintic, and then nth degree is if it's higher than 6. So you just want to be able to recognize those terms, okay? All right, let's look at adding and subtracting polynomials. all it is combining like terms. All right? So you find a like term by finding the same variable and same exponent. Okay? If it's addition, you don't have to do anything. You don't have to do anything before starting to combine like terms. You can drop the parentheses and just start finding your like terms. You don't have to rewrite it, but you can if you like it neat. Okay, so I have a 4x squared. Which term is alike to 4x squared? Your 6x squared. Very good. We have the same variable, same exponent, x squared and x squared. Now, when I'm adding like terms, just think I'm getting more or less. If I have 4x squareds over here, and I have 6 more x squareds here, if I put them together, it's 10x squareds. Okay? Then I look for my next like term. And I like to work in standard form. Notice I started with the highest exponent. That way my final answer is already in standard form when I'm done. So my next highest exponent would be x to the 1. So I have a 3x here. I don't have any more x terms over there, so 3x is by itself. I'm going to pull it down. And then I've got a negative 7 and a negative 24. Be careful of those negatives. Make sure you pull the sign to the left. So negative 7 and negative 24 would be negative 31. I'm in standard form, so that's the answer to my problem. So adding is just combining like terms, okay? All right, let's look at example 2. It's just written in a different way. Okay. Oh, I forgot to point out. Notice when I added an x squared to an x squared, the exponent didn't change. Right? You're just getting more x squared. You're not changing x squared. An exponent is representing multiplication. So if you're not multiplying, then you're not changing the exponent. Okay. Okay. Example 2. If f of x equals 12a to the third plus 4a minus 5, and g of x equals 2a to the third plus a squared minus 4a plus 9, find f of x minus g of x. So this is just a different way of writing the problem. This is what we call function notation. Okay? And in function notation, we're just naming our polynomials with a function. And we can look right here to see what to do. We want to do the f of x polynomial minus the g of x. So I'm just going to write that out. The f of x polynomial is, I'm going to put in parentheses, just to be sure, is this first one here. So f of x minus, and then my g of x polynomial. So the reason we do that is because we want to make sure we're subtracting this whole thing. If I don't put the parentheses there, look what happens. Now this subtraction is only going to the first term. We don't want that. We want it to go to every single term. And that's actually going to be the first step here. When I'm subtracting, the easiest way to avoid simple mistakes is to distribute that subtraction as a negative. So when I distribute that subtraction as a negative, it's going to change the sign of everything. A negative times a positive is a negative. A negative times a positive is a negative. A negative times a negative would turn that to a positive 4a, and then a negative times a positive is a negative 9. Nothing changes with the first one, so I'm just going to drop it down without the parentheses. All right? And I can go into combining like terms here. So I've got an a to the third and an a to the third, so that's 12 minus 2. So that would be 10a to the third. Let's see, do I have any a squareds? I do. I've got a negative a squared there, and no other like terms. Okay. Any a's? I've got a positive 4a and a positive 4a. So that would be positive 8a. And then I'm left with negative 5 and negative 9 is negative 14. Because I worked in standard form, notice my answer is in standard form, so I am done. All right, last example here. This is just a different way of wording a subtraction problem that you just have to be very careful on. It says subtract this from that. So if I want to take this away from that, I have to be careful of the order. I actually need to switch the order, okay? I want to take negative 4n squared plus 13 away from 3n minus 10n squared plus 18. All right, so notice it came second because it's what's being subtracted. Also, I put it in parentheses, okay? because it needs to be in parentheses in order to subtract the whole polynomial. So take a minute and see what you get. Okay, so I'm going to distribute that negative to take care of the subtraction and minimize mistakes, because sometimes when we subtract a negative, it's easy to make a mistake there. Okay, so that would give me a positive 4n squared and a negative 13. Bring down the first one. And now I'm going to combine my like terms. I got a negative 10n squared and a 4n squared, so you should have gotten a negative 6n squared. We only have one 3n, and that's positive 3n, and then we're left with a positive 18 and a negative 13, which will give you a positive 5. So this is the answer that you should have gotten in your notes. Okay? And that was adding and subtracting polynomials.